All right, it's 1 o'clock. We'll go ahead and get started. This session is in the intermediate track. It's called Algebra is Awesome, Write Better Calculations. So if you're in the wrong place, now's your chance to run away screaming. I promise the session will be PG. We won't do any proofs or anything that's too scary. You should be okay. I am going to do some really simple live demos and stuff later on, and if you want to be able to see those, I will enlarge them as best I can, but if that's a challenge for you, you might want to move up. And if you have FileMaker Advanced ready, you could follow along and try some of your own too. It should be pretty straightforward. You won't need a demo file because we're just going to be keying calculations in, seeing what comes out of those. All right, so who am I? I'm Chris Irvine, a developer, consultant. I have a computer science background and small business owner. I live in the northwest part of the US, a couple hours from the Pacific Ocean, and I am married, have 3 kids under 10. So if work didn't keep me busy enough, life is crazy when you have 3 little kids. So it's super fun. And I work at Prong. We're a small consulting group. We do custom solutions in FileMaker. We do quite a bit of performance optimization and B2B integrations, and some development in other platforms too. All right, so in this session, the objective here is to write better calculations. It's right in the title. And so this idea of better is maybe a little subjective in the eye of the beholder, but we'll try to maybe define that a little bit. And it also sort of suggests that there's more than one way to do things. And algebra is good for that, rearranging things in different ways that may produce the same result, but maybe in a way that's better, right? So this guy, Donald Knuth, gets quoted more than any other computer scientist, I think, but this is really helpful for some of the stuff that I want to try to get through today. He says, let us change our traditional attitude to the construction of programs. Instead of imagining that our main task is to instruct the computer what to do, let us concentrate rather on explaining to the human beings what we want a computer to do. And that has a lot of positive outcomes if you approach that. So it doesn't take long to find bad code. If you Google bad code or obfuscated code contests, you'll find all kinds of examples like this. This happens to be Perl and some Bash, and if I spend enough time, maybe I could figure out what it does. But I think it's pretty easy to see that there's a lot of problems with code that looks like this, and if there's a bug, it might take you a long time to fix it, figure out where it is. At the other extreme, if you're looking for examples of good code, a great place to start is FileMakerStandards.org. It's been around for a while. And even if you don't agree with all of their recommendations for standards, they get you thinking about a lot of things that would make your code better. Just sort of approaching writing scripts and calculations with some standards. The example here has very consistent use of syntax and spacing in a way that the consistency on its own already makes it quicker to comprehend and easier to read. Another example here, there's a bunch of things that are happening with comments that I think really helps to make the code good. So there's like an if-else statement here, and even though there's no code in here, there's a comment in the else block that sort of explains why this space is blank. Why didn't we do something in the else situation? And comments that explain why something is needed instead of what you did, tell us why you did it in the comments. That's really helpful. And consistent and meaningful naming is a huge, huge thing. And that's going to help a lot with being able to read the code and understand what it does if it's doing the right thing without really even needing as many comments. So if we're trying to define what good code is, can humans understand what you're trying to do? I think that's sort of my first benchmark. And a great sort of practical way to measure this is with code review. So if you work with a peer or you have someone else in the community, maybe if you've made a new custom function or script, you can just send a copy of it to them and say, hey, print this out, mark it up with a red pen, and send it back to me. I want to know what you think of it. Give me some feedback. If you have to watch over their shoulder and kind of coach them through the code review, then you've got a problem already. Really, you want your code to be expressive and communicate what it's trying to accomplish as it's accomplishing it so that they can just read through it and give you feedback just on its own merits. And then comprehension time, I think, is another really good measure. So sooner or later, the energy runs out. You have to stop. You can't keep coding any longer. You're going to come back the next day. How long does it take you to sort of get back up to speed? If you continually are improving the quality of your code, that time is going to be quicker. You'll be able to pick up where you're at and figure out what's going on. Weeks, months, or years later, there's probably going to be another developer that looks at your code. How quickly can they comprehend things? And then my worst critic is future me. A year or two from now, when I go back and look at my own code, I'm often pretty critical of myself. So working to continue to improve your code quality is going to be beneficial to yourself as well as other people. So we're going to get into the mechanics of the calculation engine. How does it work? And how can we make sure that we're building calculations correctly so we get the correct result, that there's not a bug, but at the same time with this goal in mind that we want the calculation to be presented in a way that's beneficial to humans, that they can make sense of it too. And we're going to start right here with order of operations. So this is starting to have some flashbacks to high school math classes. You learned about multiplication, addition, and subtraction, where things fit in. But there's quite a few other operators that are involved in the calculation engine. And this is actually almost straight out of a help page from the online help from FileMaker. If you search in there for operators, I think you'll probably land right on this page. The next thing up we're going to look at is some examples of what might be bad code. So maybe you've got this 1 plus 5 times 2. And just the way I presented it with spacing and things like that sort of suggests that I want the 1 plus 5 to happen first. But that's not what's going to happen because of order of operation says multiplications is going to have to happen first. What about this one? I've got 3 variables, x, y, and z, and I say x or y and z. What's going to happen? There's more than one way in my mind that this might be executed. If I can remember order of operations, that's good. But there's some ambiguity to the human that's reading this. What about this one? It's even more ambiguous. Not A equals B or C. This may be correct code. It might result in the outcome we want, but it's not terribly helpful for the person who's reading it. So there's some ways we might be able to change these around to get the result we want and be expressive to the person that's reading it. Lots of times that's just a matter of adding parentheses. In this case, this or and situation, it's actually going to be exactly the same result. But I just put the parentheses in for the human, for me, when I'm reading it, to make it quicker, to make sure that I did it right. And then this one, it turns out that I coded it completely wrong. And by putting parentheses in, I can get the machine to do it the direction I want. So the next thing I'm going to dive into is this idea of data types. So you're probably already familiar with field types. When you're creating a new table, you're adding fields to the table and choosing the type as you go. And for the most part, the idea of the data type is really more when we're in the calculation engine and we're dealing with a field or a variable. At that level, we're sort of talking about the type of that expression or that element in the calculation. So a lot of these are just sort of straight across the same thing. We have numbers, which are number type, dates, which are date type. These are all just straight across the same. Containers, Really, these are the same thing, container and binary. Depending on where you're at in the documentation or if you're working in any other platforms, sometimes they'll use the word container or binary data. Sometimes they'll say like blob data. Those are all really talking about the same thing. And there's a few things that we don't have field types for, but they are still data types. So there's this idea of a Boolean type, so things that can be true or false. And we don't really have a Boolean type for fields, but it can be there in our calculations. There's also this sort of ambiguous concept of an empty data type or the lack of type. This could happen when there is no related record or a field that hasn't been set yet. Sometimes the type information doesn't really apply because the field is empty or the variable is empty. And there's also sort of this edge case. Sometimes things don't go the way we expected. This is usually presented to you as a question mark. But there's this idea of calculation might return something that's invalid. And so that sort of falls outside of the normal list of types. All right, so the next idea here is short-circuiting. So this is when you start working through processing a calculation and you can stop thinking about it before you get to the end. So in this example where we have false and true, well, it doesn't really matter what's over here. Like as soon as I say false and, we're done. Like we already know that the result of this calculation is going to be false. The same can be true with or. If you have true or anything, it doesn't really matter because you can stop right there. And so that property is, we call that short-circuiting. And I'm going to do a little demo of this right now. We'll see how the demo cooperates here. All right, so I'm going to use the base elements plugin, which is open source, and it has a bunch of helpful functions, and we've got that set up in here. I've got a folder called demo on my hard drive, and I'm going to use this function. Zoom in a little bit here. So this function is pretty straightforward. It takes two elements. The first is a path where you're going to save the file, and then some text that you want to put into a text file. So if I go ahead and evaluate this, and then come over here, sure enough, it produced a file. That's good. So my plugin's working. I'm going to delete the file. And if we do something like true or this function, and then evaluate it, the base elements function, write to text file, never executed. There is no file over here. So this expression actually short-circuited after this part, and the rest of it did not run. The same could be true the other direction, false, and this function, run that, nothing comes out. And even if you put parentheses around this, the calculation engine is smart enough to look at the whole expression and know that this part doesn't matter. Even things that might be like an error, like 1 divided by 0, which would return a question mark, an invalid situation, that still returns 1 here, true, and, true or. It doesn't matter that this element over here is going to produce an error because the calculation engine kind of throws that part away because it knows it can short circuit the first half. All right. I'll just stay down here. So the way this can be beneficial to us is we can make some optimizations in our code with this short-circuiting idea in mind. So maybe we have a simple situation where we want to send a promotion to some of our customers if they're on the West Coast. So we have this expression where the state equals California or the state equals Washington or Oregon. And I just happen to know that my customers are kind of evenly distributed by population. So I'm going to go ahead and organize that calculation by the most populous state first, because it's going to short circuit after the first one in a lot of situations, and it doesn't have to run the rest. So even though this isn't probably going to make any difference for performance, to me it's actually a little more readable if I'm sort of just trying to quickly look at this and remember what it did a couple years from now. Having those things that are most likely to occur early on are helpful. We can short circuit the other direction where we want to get out as soon as possible. So maybe only 1% of my customers maintain a balance over 10,000. So putting this as the first part of the expression with an and allows me to exit before I even start looking at the state. Again, this is not really going to make a difference from performance in this scenario, but there are other times where it could matter. Right? This also can kind of apply to how you do control structures. And this is, a lot of this is sort of a preference, but for me, I would prefer to see the code path that is most of the time going to be executed over the rare case. I prefer to see the things that are going to happen through the normal flow of the script closer to the top. It's just more helpful to me as a person. But this is something where we could switch these if and else parts really easily and still get the same result. It gets a little more interesting if you're actually trying to optimize for performance, or we say optimizing for time. And so in this situation, maybe I have two conditions, like I'm looking for customers that are in California and that had sales over 10,000. In this case, I'm going to put the easy formula first to check to see if they're in California. And then I'm going to put this more expensive aggregate function as the second component. The good news here is this first expression can probably be evaluated by the calculation engine in hundredths of a second because it's data that is just right on the record I'm already on. The second part might take several seconds to compute because it involves a query and retrieving a whole bunch of records, things like that. So the benefits of short-circuiting can be a big win here for all the customers that are not in California. They can skip over that expensive part. Now you could do this in multiple if statements, but you can do it all right in the calculation if you keep in mind that part of it may not actually be performed. And the same types of optimizations you might be able to do in script steps with if and else. Now in this case, you can't just trade these and get the same result. It would take a little bit of adjustment. But in this case, even though not very many of my customers are VIPs, I'm going to run that first because it's cheap. I'll go ahead and get that out of the way. And only if they're not a VIP will I go ahead and run this more expensive calculation. All right, I'm going to switch gears again. Next up is parameters and returned types. So this is something that FileMaker gives us some information on, but it doesn't get talked about a lot in documentation. So some of these are functions that are pretty common for us to use in our scripts, like word count. And I'm going to put out here sort of a notation that explains that this function is expecting text, and what comes out of the function is a number. Thinking back to those types that were on the list of possible types in the system. Here's another case where we have a function that takes two different elements, a text component and a number component as inputs, and then we're going to get text as an output. Let's go ahead and work down the line. Maybe there are no inputs. This one comes out with a date. Some functions can return container or binary data, like the base64 decode function. There's also some types, some functions that return different types depending on your situation. So like the if function, here it says it takes Boolean or Z. I don't really know what type is here. And what's going to come out is going to be either Z, whatever that input type was, or maybe it's empty if the condition was false, right? And our operators, even though they don't have parentheses involved, they still kind of work like functions. The AND operator takes two inputs that are Booleans, and it gives us back a Boolean. So we don't always think about it that way, but thinking about it as a function that takes inputs and has an output is sometimes helpful. And then a comparator, like greater than, is going to compare things. But there might be two versions of that comparator, right? Sometimes we're comparing text elements. And there's another sort of version of that comparator that compares text elements, and they behave differently. So if you are wondering where this information comes from, it's actually in your documentation. I'm just going to flip through a few of these. So like the get value function, right here in the data type return, this is the output for that function. And sometimes we overlook this information, but it's actually really important. Execute SQL is another one. This comes up pretty often, actually, where people run into problems because they forget that execute SQL returns text. It always returns text. And that if function that takes a Boolean and something else, it could return all kinds of things, right, depending on what your inputs are. So that might throw a wrench in for you if you're expecting something else. All right, so let's talk a little bit about ordering, and this has to do with that comparator, greater than, less than, things like that. So let's say I throw out these tiles in front of you and I ask you to put them in order. This is a pretty common process for our brains to think through, sorting things, problems like that. And so we have this idea that 8 is less than or 9, so these elements are in order. 9 is less than or 10, these elements are in order, that's good. There happens to be 2 tiles with the number 11. Well, those are in order if they're equal. We still consider this to be an ordered list. So we sort of have these rules that are fairly quick to comprehend when we're putting numbers in order. But what about if we're putting text in order? We might use the same operator, but we're actually using a different policy or a model in our mind to put these together. So in a case-insensitive English approach to ordering text, the business 12 days seasonal decorations does come before 8-ball elite cues because the first character 1 comes before the character 8. And then if we have a collision where we have like Pacific and Pioneer, then we move over to the next character, right? And we compare those. So what happens in FileMaker when we run into these problems? So, or maybe we're running into these problems and we didn't realize we were. So we're just going to do a couple really simple calculations here to kind of demonstrate what's going on. So 3 less than 5. The answer is, what? 1. The answer is 1, which is how FileMaker answers the Boolean true, right? OK, what about A less than B? The answer is 1, right? What about this situation where we put a capital letter A? Sorry for the jarring. It's going to be 1, right? Because we use an insensitive policy, a case-insensitive policy for sorting our text, at least on my system. Maybe the rules are different based on your locality. What about something like this? 3 less than 5. This is also still true, but this is a little different than the one I typed in before. I put quotation marks around these numbers. So we're going to do a different formula. 30 less than 5. This is false, right? The number 30 is less than 5. That seems pretty straightforward. But what if I write it this way? 30 less than 5. The answer is going to be true, because this is an alphabetic or text comparison. Now, this actually happens a lot as a bug. So what about if we have text over here and a number over here? It's a little less obvious what's going to happen, but that's also going to be true. So it's actually a pretty common bug in looping situations in FileMaker where you thought you were working with numbers. In your head, it was numbers, but somehow your variable had text in it. And then when you go to do your comparison, the wrong policy applies. You thought you were comparing numbers. The system thought you were comparing text. And the behavior is a little cattywampus. So usually this results in a problem where you have a A loop, you expected it to run 20 iterations, and maybe it only runs 10. You're trying to figure out why the second half never executed. It's probably because you have the wrong data type on one of the sides of your comparison. So this is pretty easily fixed with getAsNumber. We put that around our text. That tells FileMaker, hey, make this 30 into a number, and then compare it. And then we get the result that I was expecting, which was to compare the number 30 to 5. Okay, so we're going to jump back out. Oh, too far. So that function I used, getAsNumber, we call that type conversion. So there's lots of ways that a number might be wrecked, in my mind, where a number accidentally becomes text, and then code doesn't work right unless I convert it back. You guys want to yell out some things that would have happened to you that convert your numbers to text? Any ideas? In a variable? In charts? Interesting. Okay. Execute SQL, right, because it always returns text. We just saw that. Any others? There's a whole bunch of them. So the JSON functions, yes, this is true. This was a kind of a bugger. So there's a few places it could come from. Maybe you have the field defined wrong in your database. In your mind, you were creating a field that people were going to type a number into, and maybe the users even type numbers into that field. But if it's defined as a text field, it's going to behave like text. If it's derived, so if you have a chunk of text and you use middle words to get a number out of it, it's still text. GetValue is one that we use to maybe combine a bunch of numbers together, send it in a script parameter, and then when it comes back, GetValue is going to give us text, so we have to be careful to make sure that gets back to a number. And anytime you take elements and put them together with the ampersand operator, you have converted it to text. It doesn't matter what it was before. When you're done, it's text. Another one that causes problems for people sometimes is if they've been writing scripts and then they decide, hey, I'm going to try this perform script on server thing. When you perform script locally, there are situations where the type can be preserved. Maybe your code was working fine. Then you switch to use perform script on server. It turns out that parameters that are passed to perform script on server get converted to text. So that could cause a problem for you, too. So these situations are easily fixed just by using getAsNumber to convert it back. You just have to be aware that that's necessary. So here's a common example of something like that, where maybe I passed through a couple parameters to a script, just using a carriage return or a line break between those. So I'm using the getValue to pull out the second one, and then I wrap that with getAsNumber, which converts that text to number, and now I'm working with a number again. And I store that in this variable, and it's going to always be a number in that variable. It's not going to lose its type unless I change the contents of the variable. Then anything could happen, right? So, but variables do retain their type as long as they exist. And this could happen with other things too. We just sort of demoed it with numbers and text, but this could happen with dates or other things. So FileMaker gives us these other type conversion functions that we can use to get those back. All right, so now I'm going to jump to this other idea that we use sometimes in computer science. We call it Truthiness. And this is in FileMaker. They don't usually talk about it this way. But if you are defining a calculation for an if statement, there's this line at the bottom. It's really important. It says non-zero values are true, and zero and empty values are false. This is FileMaker's definition of what is true. So we can kind of take that and use it to our advantage. And I like to say that some functions are truth tellers. So this function position, if we look at the documentation, it returns a number. But it turns out that the way that that number happens to work also is beneficial in Boolean situations. So we'll look a little bit at that. And also the length function is sort of a truth teller. And so let's look at a couple ways we could use that. Here's an if statement where I want to see if the phrase VIP appears in my customer flags. So I'm using the position function, which tells me where in the customer flags is VIP. Now, I could put greater than or equal to 1 right after that position function, and it would work great. But I don't need to do that because position is a truth teller. So because anything that is non-zero, a non-zero value is true, this function will give me the result I want without having to do anything more. Here's another one where maybe we want to see if there is an account rep assigned to this customer. I can just use the length function. Even though length returns a number, in this case, I can use it as if it's telling a true or false condition for this. So you could put greater than 0 in there if you want, but it's not really necessary to get the same result. So that thing I was just doing is type coercion. So this is when types of information get converted implicitly without me going out of my way to say, like, get as Boolean or something like that. So hopefully, these are intentional. I did it on purpose. I knew it was going to happen, and I expected the system to do it. It did it for me. Everything's good. Sometimes type coercion happens, and it's unintentional, and it could cause a bug for you. So knowing that it's going on is really helpful. So even if you didn't realize you were doing type coercion, I'm sure you've been doing it. Here's an example you see all the time. Maybe I'm going to create a banner value. So the formula is get current date, ampersand is going to be great. And the ampersand is expecting text on both of its inputs, and it's going to produce text. So the system is automatically coercing a date value that comes from the get current date function into text as part of this calculation. Here's another example. Maybe I'm using a truth teller like length, so I can say length of x or length of y. The or operator is expecting Booleans, but the system is going to coerce those length outputs to give me my result. In this case, it works exactly the way I want it to, without a lot of code. So as long as you're used to seeing this and realizing sort of how it's going to work for you, that can be pretty helpful. Okay, so here we're going to get into some of the flashbacks to your high school algebra. The commutative properties. So we can say things like addition is commutative for real numbers, and as is multiplication, but subtraction is not. We can't change the order of things on either side of the subtraction sign and get the same result. Boolean algebra is really just sort of an extension of some of those algebra concepts to things that are true and false, and with our and or operators. So it turns out that and or are also both commutative for Boolean properties. So you've probably already been doing this in your code and in your calculations, where you don't really worry about which side of the and you put the elements. But this is the mathematical property that says we can switch those around without any impact. We also have associative, where we can reorder basically the operations for addition and multiplication. That also works for and with Boolean values, so we can change the order these are operated if it's useful to us. Same thing with or, it's also associative. These slides will all be available for download if you haven't already grabbed them. So distributive is this idea of distributing multiplication across addition, right? Flashbacks to this is starting to get a little more of a brain drain if you haven't done this in a long time. It turns out that Boolean operators are also a distributive. So you can distribute and across or, and it follows a very sort of similar pattern to multiplication and addition. So if you can remember doing it with multiplication and addition, you can rearrange Boolean statements the same way, and that may be beneficial for you. So most of the time, we don't want to go from the left to the right. It seems like it's making it more complicated, but maybe you have an expression that looks like this in your calculation. You could potentially simplify it moving over this direction. And there might be advantages with short-circuiting and things like that once you've simplified it, where you can decide if turning things around would be good for you. This one applies more specifically to Boolean algebra, De Morgan's law. And this one is actually a bug that I see quite a bit in code that's been around for a long time, and then people add another sort of thing to the calculation. A couple years later, they add another thing. It turns out if you want to distribute not across or, you have to flip that. The or becomes and. And so that's an easy thing. If you forget that law is in place, you're going to end up with a bug in your code. It works the same way with and gets converted to or if you distribute not. And there's also this substitution form. So some of our calculations might look like this. And that can be simplified straight to x or y, where the and gets switched because of this the law. Same thing with or going to and the other way. All right. So that one is probably more useful as reference or a refresher if you hadn't really thought about it that way before. I'm going to switch gears one more time and go to this idea of an overloaded operator. I don't know if this appears anywhere in FileMaker's documentation, but it's a computer science term where we have an operator like the plus sign, or we already saw the comparator like less than can be used with different types of information. It turns out that the number sign works with numbers. That's sort of the most obvious case. But what happens if we add text with text? It turns out that the result of that we get is a number. But there's other situations where the plus operator can return things like a date. This is really useful. If we take a date and add a number, we get a date back. And if we take a number and add a date, we get a date back. So I actually want to debunk a rumor that kind of floats around sometimes. There's quite a few times I've heard people say that the last operand wins. Like whatever the type is of the last thing, that's going to be what you get. That's not true. Because here's an example where date plus a number is a date and number plus a date is a date. It doesn't matter which order. It has more to do with the policy that goes together with those. I'll jump to the next one, subtraction. This reads almost exactly the same way. But there's a few of these that don't really make sense, like number minus a date. It returns a date, but then sometimes it returns a number. So if you're doing number minus a date, it's probably a bug. But it appears that FileMaker is trying to make it into a date. But if the date can't be a date because it's too big or too little, then it pops out as a number. So that one's a little bit harder to predict. So let's do a few demos with these. All right, so the super obvious one, I'm just going to turn on automatic here. I really like this. 5 plus 3. So we put in numbers, we get out numbers. That's what we expected. What about something like 5 foo plus bar 8? So here I put in text on both sides, and I got out a number. So this is a situation where type coercion kicked in. FileMaker said, well, I can't really add text together. I'm going to convert these to numbers. It's like I put getAsNumber function in there. And then it's adding the numeric elements together. So the getAsNumber function, I don't know how the internal mechanics of it work, but it appears that it kind of just scans through the text, pulling digits out, if they look like numerical digits or if they're part of what we'd normally expect in a number, and it just discards everything else that it doesn't understand. I'm not sure that I could tell you much more than that, other than if you have other situations you want to try to use it in, you definitely should test quite a bit. Right? Good question. 67, which would be 59 plus 8, right? So even though there was some garbage in between the 5 and 9, it just threw away those characters. That's probably not helpful, right? But your program would run, something would happen, right? Good question, though. That was a good one. All right, so let's look at dates a little bit. So the getCurrentDate function, that's commonly used, right? It just kicks back the date. It's going to be formatted for my screen based on where my system is installed from. So if you are installed with a different country as your operating system and FileMaker version, this is going to look different. Or even if you just change the settings in your operating system, right? So we said that you could add numbers to dates and get dates back. So here I'm taking the current date and adding 3 to it. So this is something that's useful to do all the time, and we see this a lot in code. This also works with other things like get current time, and maybe we add 120. So in this case, we started out with a time, and the result is also a time, even though we added a number to it. The trick here is keeping track of sort of what units are you dealing with. The date function is dealing with days, so when you add numbers, you're adding days. Time, the unit of measure here is seconds, so when we're adding 120, we're actually adding 2 minutes to the current time. Yep. Yes, it will work with timestamp too. We want to see that? Yep. And if we keep evaluating, it's going to keep working. It'll be 2 minutes ahead. And as we talked about earlier, the rumor of things, the last one winning or something like that doesn't really apply. This works, same result. Okay, or we trade the time, date, timestamp, all those. All right, so there's also useful things we can do with subtraction. So here's an example of that, where we use the date function to build a date. And let's look at March 1st, 2017. So this function, if you go look at the documentation, it says it returns a date. The great thing about this is this code is really durable. It'll work in any country, and it'll output the appropriate format for your region. And let's subtract another date. Now, if we take one date and subtract another, if we went back and looked at that chart, the output of that kind of function is a number. So it's telling us the number of days between these two. And you can use this in really powerful ways for things that are tricky, like 2016, where there's 2 days between those dates. So FileMaker is keeping track of exceptions that happen in years and in months, and doing simple arithmetic with these date types makes it easy on us and puts the trickiness on the system. All right, so I'm going to jump back over here. So I'm sure if you haven't already done it, sooner or later your client is going to ask you for a report that has like this weird boundary for the start and the end, and then another one over here, and I want to see these. So let's say we have to compute the last day of next month. So I'm like, oh man, that's going to be a problem. How am I going to figure that out? So I start thinking of all the sort of exceptions, like, well, what if next month it happens to be next year? Well, what if, I can handle that. Okay, but well, maybe I can get to the beginning of the month and then come back one to get the last day of the previous month. Oh, now I'm 2 months out, so I'm going to have 2 exceptions. This kind of becomes really complicated, and it could be easy to have a bug in a formula like this. Turns out there's a much, much simpler way to accomplish the same thing by taking advantage of some behavior of some of these functions. So here I'm sort of using the same mental model. I'm going to go with today's date. I'm going to go forward 2 months and figure out what that date is. And then I just want to backtrack 1, and that'll be the last day of next month. Now there's going to be a problem here when I get to November or December, because when I add 2 to that, the month is going to be 13, 14, right? But it turns out that the date function handles that for us. We don't have to worry about it. It's automatic in there. And then because of the way we can do subtraction with two different types, with dates and a number. I can get to that date, and I can just step back one, and it's still going to be a date type. I don't have any explicit type conversion in here where I'm saying get as date. Those are happening implicitly. And as long as I sort of understand when it's going to happen, it's all going to work the way I want. The first few times you do this, it sort of takes a while to trust the system, but you can test it and kind of piece things together and get to where you want. What's that?
Are those documented behaviors by FileMaker? Because if they're not, that could change.
This is true. There are a few of these things that could change. Most of the behaviors I'm showing you have been this way for a very long time. And the engineers that I've talked to about FileMaker, sometimes they tell me things like, gosh, I wish people wouldn't write this. We made it this tricky way. And if people just did that, it'd be a lot easier. So they're sort of expecting us to use it this way. I think they probably are unlikely to change things that would break something like this. The date wrapping function, I've heard specifically from an engineer that it's on purpose that it works. So that one's good. If any of them are good, that one's good. Use that. All right, so let's do a little demo with this. So if you haven't done this before, you're going to love it. So let's look at that date function where we say 12/25, 2017. Right, we get back a date. What if we do something like +2? The date we get back is 2 months ahead. Now, really, this is the same as 14, right? It also works for negative numbers. So if I want to count back, let's say 60 days, what was 60 days before Christmas? If I evaluate, that also works. So this is actually a negative number that's feeding into the date function, and it knows how to wrap around and count backwards. Okay. That is true. I don't like to put 0 in here because it feels wrong. I don't know what the 0 day is. So I actually write this. So I know it's going to be 0, and I know it's going to work. But in my mind, when I look at the code 2 years from now, I'm hoping I'll figure out what I meant to do a little quicker. All right? This right here, so we're counting back 1 day from the 1st of December. This is the same exact thing as if we put 0. But if I go back and read this code 2 years from now, I'm going to be like, what was I doing? Why is that 0 in there? I'll just change it to 1, right? And then it's broken. You could put a comment around it that says, this is supposed to be 0. That's another option, too. Right? All right. So let's chain together a bunch of these sort of exploits that we just sort of discovered, right? We've got, maybe we want to know how many days late the customer paid this invoice. So we've got a invoiced date on our record. We also have a paid date for our payment. And then maybe we have a terms field that's text, something like net 14. So I could go to a lot of trouble to try to strip out the word net and get the 14 in there, and then I could do a bunch of type conversion. But I can write this in a really simple way. So if I just take the invoice date and try to think forward to when it's going to be due, I'm just going to add terms. And because I'm adding a date and text, this can't work. So FileMaker has to start coercing the types. So it's going to make terms into a number. When that happens, it's going to throw away the net, and I'm going to get 14 out. It turns out that when I take a date and add a number, I get another date back. Perfect. That's what I want. And then if I want to compare that to when they paid, take a date, subtract a date, I get back a number. It's what I wanted. So I'm not saying it's wrong to say get as date or get as text and put that in. The code will still work, and it'll probably perform almost exactly the same way. But if you get used to sort of thinking about what's happening sort of inside the engine, when you read this, it still kind of reads as correct, and it also executes as correct. So to me, I think it's kind of a win. You can go too far with some of this stuff. It's really hard to prove if a calculation is correct. There are scientists that just study this idea of correctness and can we prove that this program actually does the thing we want to do. It's a very interesting field, but it's not something that's easy. There's also things that can kind of go berserk when users input the data that we did not expect. So even though in my mind that thing that we just looked at here with invoiced and terms and stuff like that, what if somebody puts something strange in the terms field that I wasn't expecting, like net 14 and then a 3% discount if they pay in 7 days or something like that? Well, now all of a sudden the coercion to number comes out with something that I really didn't expect. So when you don't have tight control over the data that's being input into those formulas, things can kind of go off the rails. So doing some extra checks to make sure the data is in the format you expected before you start calculating on it is a good way to sort of avoid uncertainty. And the other thing is that if you're working with other developers and you start shortening things and taking advantage of like this truthiness behavior, it might be confusing to them if they've never seen that or heard that before. So maybe a compromise is doing something like get as Boolean length of this thing. Really, this doesn't change the result at all. It's going to be automatic if I hadn't put it in there. But it makes it a little more expressive. It sort of explains to the next person looking at the code that I meant to do this. And they might have to think about it for a second to see if it actually works, right? Some final thoughts. Going back to that quote at the beginning, this idea of concentrating on explaining to humans what we want the computer to do, I think is really useful. It helps me to be more efficient as a programmer. I want the computer to run efficiently, but I also want to run efficiently. And if we can simplify our expressions, we can comprehend them faster. And if we can comprehend them faster, we'll probably have fewer bugs, or if there are bugs, we'll be able to find them faster. And also know your audience and your subject matter. If you're collaborating with like a business owner and you look at this complicated calculation and you're like, well, I've got this, I know what to do here. I'm going to simplify this. I'm going to rearrange these things. I'm going to get rid of a bunch of operations. You might have made it faster. You might have gotten rid of a bunch of operations. But if it is so distorted from the way the business owner thinks about how his business works, then you kind of created a problem for him. So you kind of have to keep that in mind. Who's going to be looking at and reading these expressions later? All right, so we have a little bit of time left. If there's any questions or if anybody has like a burning calculation that they want to try now that they saw some of this stuff, we could do it right on the screen. And then make sure to do the evaluations. Sorry, that's the next one. There's will be some updates of these slides if you want to download them. I think they're up there now, but we'll have some updates posted in the next day or two. And then filling out the evaluations is really helpful for the speakers and for the people that run the conference. If you would do that, I'd appreciate it.
Thanks for your presentation. I wanted to ask a question about isEmpty. Evaluating, as opposed to, compared to, say, using length, for example. Right. Do you have thoughts on that?
So I think it's a preference. To me, doing if length reads a little better than saying not isEmpty, because it's sort of a double negative.
Right.
From a machine perspective, not isEmpty might be a little faster. If I am checking to see if the copy for my newspaper is empty or not, and that copy could be megabytes of text, then running length on it seems really inappropriate because you're asking for something that's potentially a lot of work to get a simple answer. In that case, I would definitely use not isEmpty. But 99% of the time, the thing I'm checking for emptiness is a very short value. There are a couple other exceptions when it's like a related record, and there's some performance optimizations where isEmpty might be faster than using length.
Right.
So I think there are certain cases where there's a performance reason to not use length at the disadvantage to the human. So you kind of have to choose the
Great.
trade-off.
Thanks.
Yeah. Can you come up or yell?
So I'm wondering why you have to use length or isEmpty, since an empty value in a field will be false, and a field that has a value will be true. Can't you just say if field, if there's something in it, it's true. If there's nothing in it, it's false. You don't have to use length, don't have to use isEmpty, just
Yeah.
if field.
I wish that were true.
Not true.
And,
Okay.
and the reason it doesn't work is for text fields. If you say if on a text field and it has the word foo in it, it will be false. So FileMaker's version of truthiness is only numerical values. The presence of numerical values are truth.
Okay, thanks.
Good question. Any more? Tips for making sort of like a little block of text that would appear in a hover condition. A tooltip, thank you. That's proper terminology. So you can certainly just concatenate things and then using the pilcrow to get those carriage returns in there. My personal preference is to use the list function. You can say list and then a value, semicolon value, semicolon value. I'm not sure if there's a performance advantage of one or the other, but list, to me, feels like a natural way to put together a list of delimited, line delimited values. So, but I see it done either way, and I think there are probably, when you're dealing with big amounts of data, there might be reasons to choose one or the other for performance reasons. Most of the time, it doesn't matter to me, so I'm just going to do whatever I think formats and reads the best in my calculation.
What about the formatting of currency in a text field? Since the formatting is handled in the layout, I've run into issues with that. Say if I'm putting the value in a letter.
So formatting currency that's currently in a text field, or?
No, putting it into a text field. So say there's a letter and it's saying you owe this amount, or whatever. Then getting the decimals to always display
I see.
has been an issue. Say if it was a...
Yeah, I mean, there are certain capabilities or limitations to sort of the formatting palette of how you can ask FileMaker to present a number on the layout. Lots of times it has enough flexibility for me. It doesn't always. And so in that situation, I end up either finding a custom function that has other formatting capabilities or taking one of those and altering it to fit my own needs. Right?
Okay, thank you.
Okay, well, I think that's it. Thanks for coming, and feel free to corner me later if you have other questions or things you want to know about.